All right, let's get into it. Today, we are cracking the code on something that's, well, literally foundational to our modern world. I'm talking about the rules for burying electrical cables, straight from the AS/NZS 3000 standard. These are the rules that keep us all safe, and we're about to see exactly how they work. Have you ever really stopped to think about what's under your feet? It's a simple question, right? But the answer, well, it's this incredibly complex web of high voltage cables, water pipes, gas lines, all running right beneath us. And getting the electrical side of things wrong isn't just a simple mistake, it can be absolutely catastrophic. That's why these standards are so critical. Okay, so the entire standard for underground wiring pretty much boils down to three core ideas, three pillars of safety, if you will. First, the cable itself has to be tough enough to even be buried in the first place. Second, it's got to have protection from someone accidentally digging it up. And third, there have to be clear warnings so nobody makes that mistake to begin with. Sounds simple, right? Well, as you're about to see, the details are everything. So here's how we're going to break this all down. We'll start with the challenge itself. Then, we'll decode these things called wiring categories. They're at the heart of the whole system. After that, we'll dive into the nitty-gritty of depth and protection. And finally, we'll see how these cables are supposed to safely share their underground space with other services. All right, section 1. The big question is, why all the fuss? Why so many rules? Well, it's because burying cables that carry a serious amount of electrical current is just inherently dangerous. These standards aren't just red tape. They're a super carefully designed solution to a very, very real safety problem. And what's that problem? What's the biggest threat? It's this: accidental excavation. The number one risk these standards are designed to prevent is someone with a shovel, or even worse, an excavator, hitting a live cable. Literally every single rule, from how deep a cable is buried to the type of warning tape you use, it's all about preventing that one disastrous event. So how do the standards manage this risk? They set up what you can think of as a master classification system. Every single underground wiring job has to fit into one of three distinct categories. And that category, it becomes the blueprint for exactly how it needs to be installed. Now, the two you'll see most often are Category A and Category B. The difference between them is really simple, but it's absolutely critical. A Category A system, think of it as being tough enough right out of the box. It's inherently suitable for being buried directly. A Category B system, on the other hand, isn't quite as rugged, so it needs an extra layer of mechanical protection to shield it from any potential impact. And then you've got Category C. This one's the special case. You'd use this when you're not digging in soil, but you're literally cutting a channel, or a chase, as it's called, directly into solid rock and then covering that cable with concrete. A rock-solid solution, you could say. And this table? This is basically the master key to the whole system. I know it looks a little complicated at first, but it's really just a matching game. On the left, you've got your type of cable. Across the top, the type of protection. And where they meet? That tells you the category. So, for example, a standard sheathed cable inside a heavy-duty conduit. Boom, that's a strong Category A system. But take that exact same cable and bury it directly in the ground without the conduit. Now, it's not tough enough on its own, so it needs extra protection, which makes it a Category B. See how that works? The protection method changes the whole game. Okay, so now that we know how to figure out the category of a system, what does that actually mean when you're on a job site? Well, it all comes down to the practical rules in action. Exactly how deep to bury it, how to protect it, and maybe most importantly, how to mark it so it's never lost. And this visual just illustrates that difference perfectly. On the left, you see a Category A system buried straight in the ground. On the right, a Category B system. See that key addition in the diagram on the right? That mechanical protection system? It could be something like a heavy-duty plastic cover strip. That's the extra layer that defines it as Category B. Which, of course, brings us to probably the most common question everyone has about this stuff. Just how deep do these cables actually need to be safe? Well, Table 3.6 gives us the exact answer. The depth really depends on the category and what's on the surface above it. But the number you should probably burn into your brain for most situations, a cable buried outside, under regular ground with no concrete slab, is right here, 500 millimeters. Half a meter. That's the minimum for both Category A and B systems. And here's a great look at that Category C system we talked about. You can see it clear as day. The cable is sitting in that chased cut into solid rock, and it's then covered with concrete. And notice this detail. The marker tape is placed right on top of the wiring system before the concrete gets poured. Okay, but what happens if the ground isn't perfectly flat? This is such a crucial detail. On a slope, that minimum depth of 500 millimeters has to be measured perpendicular to the surface of the ground. Now, why is that? Well, think about it. If you just measured straight down vertically, the cable could end up dangerously close to the surface on the uphill side. This rule makes sure it's properly protected no matter what the terrain looks like. So, once the cable's in the ground, how do you let future generations know it's there? The rules give you a couple of options for recording the location. You can either use permanent marker signs where the cable enters and leaves a building, or you can draw up a detailed plan that's kept at the main switchboard. But here's the thing that is not optional, that bright orange marker tape. It has to be placed about halfway between the cable and the surface, and it acts as a crucial early warning system for anyone who starts digging. All right, last section. We have to remember that electrical cables aren't alone down there in the dark. They're sharing that underground space with water pipes, gas lines, communication cables, and it is absolutely vital that they all keep a safe distance from each other.
So what's the magic number? Well, the starting point for safety is actually pretty simple, 100 millimeters. All underground electrical systems have to be spaced at least this far away from any other service. Doesn't matter if it's water, gas, or your internet connection.
The whole point of these separation rules is to make sure that a problem with one service, say a leaky water pipe, doesn't cascade into a major disaster for another. This table breaks down the specifics, and you can see that a 100 millimeter rule applies to most common things, like water pipes and gas lines. It's all about creating these safe buffer zones underground. So let's wrap this all up. What are the key takeaways? First, it all starts with the category, A, B, or C. That choice dictates all the other rules. Second, depth and marking, especially that bright orange tape, are totally non-negotiable for safety. Third, for Category B systems, that extra mechanical protection is the whole point. And finally, always keep your distance and respect those buffer zones between your cable and other services. You get those 4 things right, and you're building a system that's safe and built to last. So now you know the rules. You've got the inside scoop on the invisible infrastructure that's humming away right beneath our feet. I have to ask, will you ever look at a construction site trench the same way again? The next time you walk past one, you'll know the complex safety code that's being put into action, one rule at a time. Thanks for joining me on this one.